Okay, grade 7, this is your chapter review for chapter 5 on probability. These questions, the first 4 questions are really vocabulary questions, so some of you had a hard time understanding the instructions, so let me just explain how it's done. There are 8 vocabulary words up here, all of which you should know all 8 words, maybe with exception to maybe independent, because we didn't talk explicitly about the word independent variable. Okay, so our first question says probability is the number of blank outcomes divided by the number of blank outcomes. Remember, our probability says probability equals favorable outcomes divided by all the possible outcomes. That's our formula for probability. So up here we're going to have favorable. Did I spell it wrong? Oh yeah, there's a U in it. F-A-V-O-U-R. I think it's a Canadian thing. F-A-V-O-U-R-A-B-L-E. Favorable outcomes divided by all of the possible outcomes. And the second question is that the probability of an event occurring based on experimental results is called the experimental probability. And we did that with the coin flipping experiment with Nichols Jr. partner carried out the experimental probability. And we said the theoretical probability that we were looking at for flipping 2 coins and getting heads was 25%. And when we conducted the experimental probability, we took 140 coin flips. And if you remember, we had 33 out of the 140 landing on heads. And that translated into, I think, approximately 23.6%, which was close to our theoretical probability, but not the same. And the last question says, a blankety blank and a table are 2 ways of organizing outcomes. A tree diagram, or a tree diagram, and a table. So then it says rearrange the circle or the circled letters in 1, 2, and 3. So in the first one we have an O. In the second one we have an N. In the third one we have an R and a D and an M. And an A. Which one am I forgetting? A. Oh, up there, A and an A. Okay. And it says rearrange the circle letters in 1 to 3 to find the remaining key word. So if we look up here, if we re-scramble them, it would be random. The word is random. Question 5 says a toolbox contains 3 screwdrivers and 2 wrenches. So I'm going to draw the box, and I'm going to put just a screwdriver, and a screwdriver, and a wrench inside that box. I guess I have cards, but I don't need it for this one. It says, what is the probability that she grabbed a wrench? Write your answer as a fraction, a ratio, and a percent. So there are the probability of an event, in this case, probability of a wrench is going to equal favorable outcomes divided by all of the possible outcomes. So therefore, the favorable outcomes, we have 2 of them. That would be drawing either one of those wrenches. So there are 2 possibilities out of 5 total tools in total. So we say 2 to 5, or as a ratio 2 to 5. But more importantly, as a percentage, you have a 40% probability of drawing the wrench. I should copy this because I think I'm going to need this for the next question. So I'm going to copy it. Yes, I made a mistake. So we'll need this picture up here. I'll just shrink it so it's smaller. Okay. There we go. So question 6 is Millet, I think that's how you pronounce her name, chooses a card at random from the following set right here. Each probability is a fraction, a ratio, and a percent. So the first one says, what is the probability of red? So the probability of red. Well, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 total cards. And of those 10 cards, how many of them are red? 0. So the probability that I will draw a red card from that deck is 0% chance. What is the probability? This is question B. What is the probability of a 3 or a 4? Well, we still have 10 possible outcomes, but this time 2 of those are a 3 or a 4, which means we have a 20% probability of drawing the 3 or 4. or an 80% probability of not. That's another way of looking at it. And C says, what is the probability of choosing a multiple of 3? Well, how many multiples of 3 are there? Well, 3, 6, 9, 12, those are multiples of 3. So we have a 3, we have a 6, and we have a 9. We have 3 out of 10, which translates to a 30% probability. And the last one, what is the probability of less than 7? Of the 10 cards we have here, 6 of them are less than 7. So we have 6 out of 10, which is a 60% probability that you choose a card that is less than 7. Question number 7. Oh, hang on one second. Okay, question number 7 says a chef tapes the word salad to one side of a coin and cooked to the other side. And then he makes a spinner like this. Now the only problem is that broccoli looks like it has a much larger area of that circle than beans and carrots, but we'll pretend they're all equal sized. He flips the coin and spins the spinner once to choose the vegetable for the night special and how he will prepare it. So the easiest way for me to create a sample space is to draw a table. And I'm going to put the word salad up here, and I'm going to put the word cooked over here. That's going to represent that coin that he made up. Why he would do that, I don't know. But anyway, he did. And then I'm going to put broccoli, I'm going to put beans, and I'm going to put carrots. Okay? So our sample space is actually all of the possible outcomes that could happen. And we see that really clearly in a table. We see that there are 6 possible outcomes. He could have broccoli salad. He could have broccoli cooked. He could have bean salad. He could have cooked beans. He could have a carrot salad, which I can only imagine is gross. And he could have carrots cooked. Okay, so of the 6 possibilities, those are them. So it says list the sample space. Well, rather than rewrite them all out, since I filled in my table, this is our sample space. And remember, our sample space is really a way to say all possible outcomes. All right, that will show you everything that's possible. Question 8 says, at a restaurant, Carrie decides to close her eyes and randomly point to one dinner and one dessert item on the menu. She's crazy. Why would you do that? Why would you randomly just choose, I don't know, just eat what you like. But anyway, she did that. So we're going to make a table. You could do a tree diagram too, but we're going to put chicken quiche up here. We're going to put fish burger. We're going to put hamburger surprise, which I think sounds incredibly gross. So clearly I would never order hamburger surprise because what are you surprised about? Is it like the meat's not really beef, or is it like what is surprising about the hamburger? I don't know. I wouldn't eat it myself. Or the vegetarian special. I'd probably gravitate to that. Then you can have your ice cream sundae and your apple pie. So clearly when we look at our sample space here, we see that there are 8 possible outcomes, none of which are really overly appealing. And how many, draw a diagram, so that's our diagram. And how many dessert combinations are there? There are 8, right? I probably, if I had to choose one, I'll probably go for the grilled fish burger with apple pie. That would be my choice. Anyone else? Anyone else? Hamburger surprise sounds gross. Question 9 says a coin is flipped twice. Now, by now you should all know what the possible outcomes are because we've done it several times. But if we were to draw a tree diagram, we would put heads here and tails here. Our possibility for heads is one combination. Another possibility would be heads on the first, tails on the second. A third possibility is tails on the first coin and heads on the second, and tails on the first coin and tails on the second. So at the end of each branch, if I take a different marker here, one possibility is heads, one possibility is heads, tails. One possibility is tails and then heads, and the final possibility is tails, tails. Now a tree diagram is not the best option when you have two events. The best option you have is to make your table. And we looked at it last time. And when we make the table, it's much clearer to see four possible outcomes. And if I put a check mark here, that would be the check mark for which outcome am I looking at. That's heads, heads, right? And we can see different things. So I would always recommend that. So it says, what is the probability in B of flipping two tails? So of all these possible outcomes, there's only one that is tails, tails. So just like heads, heads, it's one chance out of four, or 25% chance of flipping two tails. Question 9 says a coin is flipped twice. Didn't I just do this? I copied the question, didn't I? Question 10. A toolbox contains a hammer, a screwdriver, pliers, and a tape measure. A pail contains one nail, 4 screws, and 2 hooks. Create a table to organize all of the possible outcomes. So I'm assuming choosing one thing from the toolbox and one thing from the pail. So I'll make it here like this. We'll go hammer, we'll go pliers, we'll go screwdriver, and we'll do tape measure. Here we'll go nail, screw, screw, another one, another one. Yes, M. And 2, what do the H's stand for again? Hooks. Okay, so there is our sample space. We have hammer, pliers, screwdriver, and tape measure on top. Nail, screw, 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 hey, hook, hook down below. So it says, what is the probability of getting a hammer from the toolbox and a nail from the pail? So what I'm going to do here, I could fill in my whole sample space inside this table, or I could simply put a check mark on every part that's the hammer and the nail. How many of them are there, hammer, nail? Just one possibility out of how many combinations? There's 4, 4, 4, 4, 4, 4, 4, or 4 times 7, which is 28 possibilities. So there's one chance out of 28, which has a percent. Don't forget you can do that. If I took my, I don't have my calculator anymore, I got a new thing. Would be roughly what percent if I was estimating? What's a good estimation for that? What do you think? 3's not bad. What's a better one? 4%. How come? Because 1 out of 28 is pretty darn close to 1 out of 25, and we know that one. That's 4 out of 100, which is 4%. So 1 out of 28 is probably, is it more than 4% or less than 4%? Less than 4%, because you got worse on the test. If you got 1 out of 25, you got 4%. If you got 1 out of 28, you probably got less than 4%. Okay. And what is the probability of a tape measure screwdriver? Is that even possible? No, because in that second thing here, there are no screwdrivers in the pail, so you can't pull out a screwdriver from a pail that has no screwdriver, right? Unless you were reaching into just the box. Now here's an interesting one. Let's assume for a second that we were just reaching into the toolbox. What's the probability of pulling out a tape measure on the first one? What is it? 1 out of 4. But if that was gone, what's the probability on my next one I pull out the screwdriver? What do you think, Sammy? 1 out of 3, right? So what you really want to do is you want to find the average of those two events, which we haven't learned yet. So we're going to assume, because this would be a grade 8 outcome, you're going to learn how to combine those two in grade 8 or grade 9, but not in grade 7. No, because we haven't learned how to add fractions yet. I'll tell you later. Question 12 says, a spinner is spun once. Draw a tree diagram to organize the sample space. So, oh, isn't this cute? L, O, V, E, Y. Oh, did it say tree diagram? Do we have to? Well, let's do a tree diagram. Shh, let's do a tree diagram. So L-O-V-E, and then Y-O-U. Now I have a benefit, don't I? I can take this and I can infinite clone it. Right? So when I do this, I'm able to do it much faster than you can. But how many possible outcomes are there? If we look here, there's 1, 2, 3, and there's 3 in each of them. So 3 times 4 is 12 possible outcomes. It says, what is the probability of getting 2 letter O's? There's 1 here, isn't there? Is there any more OOs? So it's just 1 chance out of 12. What percent's that roughly? What roughly, I said. Approximately. What do you think? 1 out of 12, approximately. Yeah, go ahead. More or less than 10%. Less than 10%. Probably around. A good guess was 8%. That's not a bad guess. If I had a calculator, I'd show you, but I don't have my calculator anymore, so I can't tell you. But probably 8% is a good guess. 8.5%. 8.3 repeating percent. Question C says, what is the probability the letter will not be the same on both spinners? So this time, I'll use my red marker. Not the same. Not the same, not the same, not the same. Is the same. Not the same, 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 not. How many are not the same? 11 of them out of 12. Which, let's say, for example, 1/12 was 8%. What's a good estimation for 11/12? If 1/12 was 8%, what should 11/12 be, roughly? If 1/12, if we said this is approximately 8%, who has a good guess for what 11/12 is? How much less than 100% would it be? So what's a good guess then for percentage? 92% would be a good guess. Maybe. That make sense? 8% less than 100%. Okay. Is that the last question or one more? One more. A spinner with 4 equal sections labeled A, B, C, D. So this is just like the one we did with coin flips. It is spun 20 times. And the following tally chart records the probabilities. So 4 out of 20 was this. 6 out of 20 was this. 7 out of 20 was this. And 3 out of 20 was this. So what is the experimental probability of each? What did we get for percentage for A? What percent was A? 4 out of 20. What percent's that? Sammy? Not 4 out of 20 is not. What is it, Miss Gauthier? 20%. Because 4 out of 20, if I think of it as an equivalent fraction, it's 20 out of 100, right? Which is 20%. What is our experimental probability for B? Do you want to try that one? What's 6 out of 20? What percent would that be? It is 30%. Because 6 out of 20, I multiply by 5 and multiply by 5. I get 30 out of 100, which is 30%. What about 7 out of 20 for C? 7 out of 20 is how many out of 100? Ms. Gauthier? Who knows? No. What is it? 35, which means this is 35%. And D, 3 out of 20 is 15 over 100, or 15%. But what was the theoretical probability of C? Before we actually started spinning the spinner, what should have happened on C? How often should it have landed on C theoretically? 1 out of 4, because it had an equal chance of the 4 letters. The theoretical probability was 1 chance out of 4, but the experimental probability was 7 times out of 20. Are they equal? No. But why not? Why didn't they happen? Yes, but your sample size was too small, right? You only spun it 20 times. If she spun it 1,000 times, just like when we flipped the coins, the more we did it, the closer we got to theoretical, right? Okay, any questions with that? Yeah.